our current dBi, our gain, and so forth. So we need to make sure that we understand what the effect of these radio frequency accessories have on our wireless LAN. There are many wireless LAN accessories that you're going to have to expect to use when you're dealing with a wireless LAN. And when it comes time to connect all of these LAN devices together, you've got to make sure that you do purchase the appropriate cables and accessories that will maximize the throughput for your radio frequency, minimize the overall signal loss, and most importantly, allow you to make all the appropriate connections. We are going to have to discuss several radio frequency accessories that will make this possible. Radio frequency amplifiers and attenuators, lightning arresters, radio frequency connectors, cables, and splitters, as well as pigtails. Now, each of these devices is very important to building a successful wireless LAN, but some of the items in the list are going to be much more important than others. While some are mandatory, some are optional. It is likely that you as an administrator will have to install and use all of these items multiple times when implementing or managing a wireless LAN. The first object that we want to look at is the radio frequency amplifier. As its name would suggest, it is an amplifier for radio frequency, used to increase the amplitude of the signal itself. This positive increase, remember, is called gain, and it's going to be measured in decibels, positive decibels. An amplifier will be used anytime we have to compensate for loss incurred by the RF signal, either due to distance between antennas or the length of cable from a wireless infrastructure device to its antenna. Most radio frequency amplifiers that are used with wireless LANs are powered using DC voltage that's fed right onto the radio frequency cable with a DC injector near the radio frequency signal source, such as the access point or bridge. Most of the time when you plug your antenna directly into your access point, you won't have to worry at all about a radio frequency amplifier. But if that cable length should grow to a certain point, radio frequency amplifiers are definitely important. Sometimes the DC voltage which is used to power up the radio frequency amplifier is called phantom voltage. And the reason why is because the radio frequency amplifier will sometimes seem to magically power up. Now, the DC injector is actually powered from an AC voltage wall outlet, so it might be located in a wiring closet, and that's kind of why we see this phantom voltage occur. In this scenario, the radio frequency cable will carry both the radio frequency signal and the DC voltage, which is necessary to power the inline amplifier, which in turn will boost the radio frequency signal amplitude when it's applied. The amplifiers themselves will come in two different types, unidirectional and bidirectional amplifiers. Unidirectional amplifiers will compensate for signal loss incurred over very long radio frequency cables by increasing the signal level before it's injected into the transmitting antenna, whereas bidirectional amplifiers boost the effective sensitivity of the receiving antenna by amplifying the received signal before it's fed into the access point, into the bridge, or even possibly to a client device. Bidirectional amplifiers should always be placed as close to the antenna as possible so as to effectively compensate for any cable loss between the antenna and the receiver. Most amplifiers that are used within a wireless LAN are bidirectional and are preferred for use because they can boost and clean up weak signals that are coming into the antenna before the signal is passed onto the receiving device. There are some common options that you'll see with radio frequency amplifiers. Before you ever decide which amplifier to purchase, you should already know the amplifier specification requirements. Once you know what the impedance in ohms, the gain in decibel, the frequency response, which is the range in gigahertz, the VSWR, the input, and the output specifications, you will finally be ready to select the RF amplifier. Frequency response is likely the first specification that you should decide upon in this case. If a wireless LAN uses a 5 gigahertz frequency spectrum, an amplifier that only works in the 2.4 gigahertz spectrum is definitely not going to work in that situation. So determining how much gain, input, and output power is required by performing math calculations prior to purchase of an amplifier is your best course of action. The other thing that's very important with the amplifier is that it needs to match impedances with all of the other wireless LAN hardware between your transmitter and your antenna. Generally, the wireless LAN components have an impedance of 50 ohms. However, it's always a good idea to check the impedance of every component of the wireless LAN before you actually purchase your amplifier. Last thing that you want to have is an issue with output power. Keep in mind that your amplifier must be connected to the network with all of the other radio frequency devices. So make sure that your amplifier has the same kinds of connectors as the cables and antennas that it's going to be connected to. Typically, your radio frequency amplifiers will have either SMA or N-type connectors. Both of these perform well and are widely used by most different devices in the radio frequency realm. There are going to be some special stipulations that you'll want to watch out for with amplifiers. First and foremost is the FCC's CFR 15.204 requirements. And this states that every system that's used in the ISM and UNII bands must be certified as a complete system and given a certification number by the FCC. This certification will be accompanied by an actual certificate that will list the pieces of equipment and their FCC identifiers that are permitted for use within that specific wireless LAN system. All pieces of the wireless LAN setup that are used must be listed in the certificate, as per the FCC's stipulation. Understanding this requirement becomes especially crucial when you're dealing with amplifiers, because a system is defined as the transmitting device, the cabling, connectors, amplifiers, attenuators, splitters, and the antenna itself. And manufacturers obtain FCC approval or certification of their hardware such that an end user may purchase any of their radio devices and antennas and use them as a system without having to contact the FCC additionally for testing and certification. But when additional devices such as amplifiers are added into the system, the manufacturer's certification no longer applies, and a user must obtain their own certification of the system. This process might cost as much as $12,000 per system. Well, an answer to this problem without having to spend the money might just be to purchase an FCC certified system from a reputable vendor that does meet all of the requirements of the wireless network. The CFR 15.204 does not allow an amplifier to be marketed or sold when not part of a certified system. The FCC does maintain a database of certified systems and all the companies that hold these certificates. So you can check that out at the www.fcc.gov website, where all this information actually is derived. Now, this website is meticulously maintained by the FCC and is always current. Typical updates are a minimum of weekly, and the end user is always liable for violations of FCC rules anytime they use the equipment. So you've got to make sure that you're up to date. FCC violations may result in fines of anywhere from $27,500 to $1.2 million per violation. So this is definitely serious stuff. The FCC usually allows a violator a brief, like 10-day window to correct the problem and report to the FCC how the violation was repaired. It's not uncommon for the FCC to audit a wireless ISP looking for certified system infractions, so be aware of that. Also, many manufacturers do not produce amplifiers to be used with their systems. And for this reason, there are companies that produce amplifiers but not wireless LAN hardware that obtain the FCC certification of an entire wireless system. Therefore, you may have some mixed vendor situations. So be very, very careful in what type of amplifiers that you actually buy. And that some amplifiers will cause the FCC to only certify the system as being able to use particular channels, such as the DSSS channels 2 through 10 or 3 through 9 instead of 1 through 11, like an unamplified system can. This is due to how the RF signal is amplified and bleeds over into the licensed radio frequency spectrum outside of the ISM or UNII bands. The other thing that's very important is the FCC CFR 15.203 says that installers are responsible to make sure that intentional radiators are used with authorized antennas. Antennas may be made such that they can be repaired, but not attached to non-certified matching intentional radiators. This is very important. Well, probably one of the most common questions that should be addressed regarding this special stipulation of 15.204 is that one manufacturer's antennas may not be used with another manufacturer's intentional radiator without FCC certification as a system. And this ruling will directly affect those individuals that would connect a Pringles can antenna to a PC card for the purpose of war driving. What this does is to incur a potential fine of up to $1.2 million if caught. That's per violation per Pringles can antenna that's connected to a PC card. So be very careful with those situations. Make sure that you use nothing but certified equipment. Another major component that you'll have to deal with in radio frequency wireless is RF attenuators. Radio frequency attenuators are devices that are designed to cause a precisely measured loss in a radio frequency signal. This is always measured in negative decibels. While an amplifier is designed to increase the RF signal, attenuators decrease it. So you're asking, well, why would I want to decrease my RF signal? I'm normally trying to boost it. What's the reason for this? Well, try to identify